How you doing?
Great.
There are any front-end developers here? Who is a front-end developer? Yeah, it's a safe place. Amazing. Yeah. Hello, everyone. Can you see my slides, or at least the first one? Question not for dummies. Okay. So my name is Marta Wiśniewska. I'm from Poland. I am Google developer expert in Angular and web technologies. And today I will tell you about Core Web Vitals, how to keep it under control, how to improve the performance and user experience of your web apps. So Core Web Vitals, this is a set of metrics, user-centered, that Google uses to rank web apps that uses in their search engines. And today I will tell you which exactly metrics build this set, what are the causes of poor results for them. Then I will tell you about the tools to debug and test Core Web Vitals. And last but not least, I will show you more practical examples, my learnings from a project in which I tried to focus on Core Web Vitals to improve on existing Angular projects, the metrics. And before I start, I want to introduce my assistant, because every time when I'm speaking, I wish I could have an assistant, a person who can ask some questions, or for example, reminds me about some topics. And to select the proper one, I was thinking about two main requirements. The first one is that this person needs to be familiar for most of the audience, and the second, that needs to be experienced. And this is my selection. I hope you know him. This is Clippy from Microsoft, legendary, right? So, and there is a fun fact about Clippy. So some time ago, Microsoft challenged his user and posted this tweet on Twitter. And they wrote, if this tweet will receive more than 20,000 of likes, they will create the emoji of Clippy in Microsoft 365. As you can see, it received much more, almost 9 times more. So there's evidence for me that people like him. And the second fun fact is this is the transformation of Clippy from the initial version in Microsoft to the current one. So this is, like an IT transformation from legendary Pikachu to Raichu. What is he? It looks like we're not talking about Core Web Vitals. Need some help. Thank you, Clippy. Yeah, it's a good suggestion. So yeah, let's talk about the Core Web Vitals. So what we have, this Core Web Vitals, how it happened that we started to measure somehow the user experience. So one day, Google engineers were trying to find a way, okay, how we can say that this app is better based on the user experience, which not, because actually the user experience is quite relative. Like for some users, the same app can be good, but for others not. So they decided to find like the most universal factors that are rather noticeable by human senses, and based on these factors, they started to measure some metrics to be able to qualify the web apps. And the first factor that they consider, it was loading time. So how the app is fast. So I think for everyone, this is a crucial one. The second factor, it was interactivity. So how fast the app responds to user interactions. And the last one, visual stability. So it means how the layout is stable while we use this app. And from the other perspective, if you will think, okay, what is the most annoying for you if you use web apps? It's the opposite, right? So apps are slow, they don't respond or do something different that you want, are not stable because there are like different strange elements, for example, appear on the screen. Okay, so let's take a look at the metric that represents and measure these factors. So for the loading time, Google's engineers decided to select largest contentful paint, and don't be confused with first contentful paint. So largest contentful paint is measured after the largest content element is visible in the viewport. And they did many tests on different web apps, and they created some zones on which we're able to say, okay, this is a good time, and we can say that this app is fast. And after this test, they decided to create this green zone that was for results below than 2.5 of the seconds. They say, okay, we can see like how are different results for different apps. So let's say that between 2.5 and 4 is okay, it's fine, but can be improved. And for apps with higher score than 4 seconds, it's highly recommended to be improved. For interactivity, they decided to measure first input delay. So this is the time that is measured after the first user interaction. For example, after first click or after first scroll. And there are also some zones, let's say. Green zone, this is below the 100 of milliseconds. Between 100 milliseconds and 300, it's fine, but can be better. And for scores higher than 300 milliseconds, it's highly recommended to take a look at this and try to improve it. And for visual stability, of course, they won't measure time, but rather a value. They try to find a value that will somehow represent the instability of the page. So at the beginning, it started to measure layout shift value that actually represents, like, in percentages how it's like not expectable. But in the end, and it represents actually the layout shift value, it represents a single point in time. But at the end, they wanted to somehow estimate the total instability of the page, and they decided to measure cumulative layout shift. And there are the results, like they decided to set as the main values. So for the green light, let's say the good cumulative layout shift is okay, it's 10%, so that are almost changes that are not visible by human senses. Between 10% and 25%, okay, it's fine, but could be better. And for more than 25%, okay, this app is really hard to use because it's not inspectable. So now, Clippy. It looks like you haven't explained the good threshold, needs some help. Thank you, Clippy. Actually, it's a good point because you can get different results for the same app, but in different conditions. So it really matters the network conditions, the device that you use. And Google engineers decided to create, like, to be sure that they're hitting the recommended target of most of the users. And they set like 75th percentile of the page loads that was segmented across mobiles and networks, and desktop, sorry. And now I want to tell you about these metrics, what are normally the poor results, the causes of poor results for them, and how you can improve it. So the main reason of poor largest contentful pane is a slow server response time. And to improve it, take a look at your server and try to optimize it. Remember about CDNs, that you can route users to an RBCDN, but also you can use caching, different caching methods, and yeah, try to implement service worker. For slow resource load time, the main reason of poor results are big assets. So try to optimize your assets, and there's a lot of potential to improve the performance of web apps by improving only images. So try to focus on using the most modern, the best formats, and try to also optimize the size of your images, but also other assets. For the last 2 points, for render blocking JavaScript and CSS, and for client-side rendering, so try to optimize the amount of your code. The less code, the better. And also take a look what the part of your codes are critical and which one not. So for example, for critical CSS, try to inline it. For not critical, defer. For JavaScript, remove all necessary trash or unused polyfills, and so on. And for the last point, for client-side rendering, remember about other ways of rendering, for example, server-side rendering or pre-rendering. So now let's take a look at the causes of poor first input delay. So the main reason are long tasks. So try to break down long tasks into smaller asynchronous tasks. For long execution time of JavaScript and render blocking JavaScript is the same as in the previous slide. So try to optimize the amount of JavaScript. For large JavaScript bundles, try to apply code splitting methods and split your bundles into multiple smaller chunks. And for cumulative layout shift, so the main reasons of poor results are elements without dimensions, because if we don't set the dimensions for the elements, we don't reserve space on the layout for these elements, and then we can have some unexpected effects. For dynamically injected content, sometimes there are animations. So Google Chrome team recommends rather use to transfer animations than animations of properties. But also the same, that if you expect in some places that content will be injected later, so try to handle it by CSS, if it's possible, of course. And the last thing that are fonts, because that are also the main cause of the poor results for cumulative layout shift. So one thing is that you can use some techniques to preload your fonts. There are some APIs like font loading API that allows you to load the key fonts faster. But also there are some CSS properties like font display that allows you to modify the behavior of loading fonts and tell you what is the block period between you display the text. And to improve the cumulative layout shift, Google Chrome team recommends the font display set to optional and also combined with preloading for key fonts. So it's like this combination. Now let's take a look at the tools that allows you to measure these metrics. So in general, we can divide them into two kind of tools. Tools in the lab that allows you to measure a simulated environment, like for example, Lighthouse is this kind of tool, but also Chrome Dev Tools, Web Page Test, and Web Vitals extension. But for tools in the field, we measure the data on, let's say, real data, aggregated data that real users experienced. And the main tool of this is Chrome User Experience Report, but also the Search Console and Web Vitals JavaScript library. Okay, so there is a question, which tools are better? And the answer is the most common answer in IT. That, of course, depends. It depends what you need. So if you want to have really accurate reports, then use labs tools in the field. But if you're rather looking for the issues in your user experience and you want to fix them, rather use tools in the lab because it allows you to track these metrics during, for example, implementation. And this is how you can easily measure the Chrome Vitals in Chrome Web Tools. So if you open the tab Performance, if you select the checkbox Web Vitals, and you start auditing, you can see the 3 dots. So you will see in a moment, like this one. So this is the fastest way to check it in Chrome DevTools. And this tool is based on Lighthouse. And there is a big secret how to keep under control the core Web Vitals. So you can, for example, integrate Lighthouse and budget.json file with GitHub Actions. So in the budget.json file, you can set some requirements for some metrics that you want to measure, which are like the specific budgeting. And also, then you can integrate GitHub Actions, which means that this audit test will be run every time when you raise the pull request. And this is how the budget.json file looks like. So you have just specified metrics and the budget for different metrics, but also, for example, for the maximum load for scripts or for images. So it's a really nice way how you can control exactly which pull request, for example, can cause issues in your core Web Vitals. And yeah, this is also a very nice tool. This is just a Chrome extension, Web Vitals Chrome extension that gives you exactly the 3 metrics and the results with the proper color of the zones. And if you need something that you want to use inside your code, there's like Web Vitals JavaScript library that you can easily install like a normal node package. And it allows you to measure just 3 metrics, but also first contentful paint and time to first byte, so a bit more metrics. And this is how you can use it. So the basic usage is like it shows you the results for each metric. But of course, it's not very useful for us as developers because we rather prefer to track it somehow. So one thing what you can do, you can just create a database and just send it to database. But another way is just to integrate with Google Analytics and send the events as a Google events. So this is the Google Analytics panel, and here you can see that these metrics are tracked as a normal Google events. Yeah, now Clippy is saying that we should show our learnings. So I will tell you about my app that I was just auditing and was trying to improve the core Web Vitals. So it was an Angular app. It consisted of 3 pages. The first one, it was just a normal page for shop when you could see the list of products. The second page, it was a blog when I could see the different photos, a long list of photos with so many images. So there was implemented infinite scroll, but as you can see, it wasn't loading so fast. And also on this page, there's like posts, list. It was a bit faster, but all because it didn't have images. Yeah, those are posts. And the last tab, it was a kind of YouTube player. When I click on a thumb on the carousel, I was able to play a YouTube video. Okay, so it was an Angular app that I created when I was a student. So it was like a few years ago. So you can imagine my face when I started to review my code. Is every time when you, after some time, you try to review your code, it's super funny for you. But I thought, okay, I will try to do some tests and only focus on this aspect. And I used just for me the simplest way to do it. I only needed these 3 metrics. And I wanted to find, let's say, the weakness point of this app. And I noticed that the weakness point, this is cumulative layout shift. I decided to take a look at the code and wonder what are exactly the issues in my app that causes this cumulative layout shift. And this is the perfect explanation for me what is exactly cumulative layout shift. So the perfect situation is on the right side, yeah, also for your right side, correct? So if you click in the element, you exactly do what you wanted to do, even if the full elements are not loaded. On the left side, you can see that you, for example, want to click the specific element on your app, but it's loaded. So in the end, you click something different and you do another action. So this is a cumulative layout shift, like 44%. It actually says that your app is not really stable and you're not able to predict what you will do in this app. So the first issue I found is like most of the images didn't have specified the sizes, also iframes. It was the same issue. So what I did in the first step, I tried to add all dimensions for all my images. So also, it's my first learning and also tip for you. Always remember about dimensions of your images, but also videos and iframes. There's also a nice tip with aspect ratio CSS property. So if you don't, or you can't, or you're not able to specify from the beginning the size of your images and other elements, then you can just say about proportions. And this, it's true. The property seems to be new, and it's good to take a look at the browser support. So aspect ratio actually has very good browser support. It's not supported by Internet Explorer, but we don't care anymore, right? And the second point I found that it would be nice to do, I did lazy loading, native lazy loading. And also maybe Clippy will ask about the browser support. So actually, lazy loading works with Chromium Power browsers. So it won't work with Safari and the browsers with the same engine. But actually, if you really want to implement it on all your browsers, then you can implement on your own with Intersection Observer API, or there's like many tools already created, libraries to allow you to lazy load images, but also iframes. So the second tip in my learning, lazy load images and iframes. And now I want to tell you about this thing that I found on the carousel with videos. So I noticed that it's loading very slow. And then I noticed that I implemented it very strange way, that against like normal carousel, I implemented these videos as iframes. So actually, they were like render blocking elements. So I just decided to replace it with normal thumbnails with images. And there is a nice way how you can, this is one more time. The next tip for you, use light thumbnails and placeholders for HTML elements. And this is a tip how you can do a screenshot of any element of note in your browser. So if you click the specific node, you can click mouse button, capture node screenshot, and then you will take a screenshot of your element as a PNG. So I did it for each of these iframes. And then, of course, I wanted also to format and compress these images. I decided to use WebP image format. As you can see, the browser support is very good right now. So, OK, I did it. And actually, I used the easiest tool that I found. I had only like 6 images. So I use this tool. But if you need, like, for example, much more, there are some Node.js tools that allows you to convert multiple images. And it was the result. So I replaced these images, of course, also with lazy loading, with other dimensions, and with much better compressed and format images. So as you can see, the reloading was immediate. Yeah, so that are the carousel after the change. So next tip, compress and optimize all your images. And the last thing I found in this carousel, it was that when I click first element in the carousel, like I mean the first video to play, then the video appeared, but actually the carousel moved down. So it also was kind of cumulative layout shift. And what I decided to do, I decided to create a placeholder for this iframes with video. Of course, I did also like prepared image for this to replace it for the time until I run and select the proper video. So it was the effect. Also, of course, I did format before, I compressed this image. So it was the view from the beginning. So if I click the first video to play, it only replaced image with this iframe, but it didn't have this move from the top to the bottom. So next learning and tip, reserve space for HTML elements, but adding placeholder. That will be, of course, light. And the last thing I did, I was working with fonts. So I did preloading for the key fonts and also applied this font display property of CSS to set it to optional, so the fastest way to display any text. So also a tip for you, remember about this technique. Maybe it makes sense for you, and maybe also it will improve and fix your issues with cumulative layout shift. And my final measurements after all these things, you can see that everything was in green zone. So actually it improved, especially the weakness point, the cumulative layout shift also was improved. So yeah, the summary of my learnings. So I hope it be also useful for you and you will implement in your next web apps. And summary, so you know the issues I did. So remember that the best thing is to prevent against repairing. So now try to, if it makes sense for you, to implement in your daily implementation. And remember that only recommendations of Google Chrome teams and still these measurements and way how they measure still change. So rather use it as a way of thinking what are your issues, but not the really precise results and measurements. And also remember that it's still quite new and it can change in the future. So it doesn't mean that in the future the same metrics will be, and the same results will show you for the same app. And that's all from my side. Thank you for having me. I hope you learned at least a new one thing. So if you have any questions now or later, or if you want to have access to my presentation, please reach me out now or by Twitter or as you want. Thank you so much and have a good day.